Hello, I am Tushar Bhand, and this is my Emertex internship project. Title is Microwave Oven Simulation using PICSIMLAB. The aim of this project is understand the working of embedded system by simulating a microwave oven using PICSIMLAB software. This project demonstrates basic microwave function like time setting, start and stop operation. By using simulation, we can test the system without real hardware, which makes learning easy, safe, and cost effective. Overview of the internship. During my Emertex internship, I learned the basic of embedded system and microcontrollers. I studied three programming concepts such as conditional statement, loops, operator, array, pointers, functions, and string. I also learned about storage classes and gained basic knowledge of embedded system and microcontrollers. For practical implementation, I work with MPLAB IDE, X8 compiler, and PICSIMLAB software. I, al- I also learned how to interface different peripherals with the PICSIM PIC16F877A microcontroller, which help me understand real-time embedded applications. Next slide is goal and contents. The main goal of this project is develop a microwave oven model using PICSIMLAB. First, I will give a brief overview of microcontroller, microprocessor and embedded system. Then I will explain what a microwave oven is and its basic working. After that, I will discuss the project requirement. Next, I will show the block diagram of PIC16F877A and explain its peripheral features. I will also explain the role of interrupt and ISR used in project. Finally, I will demonstrate the project implementation and its working. Next slide is microprocessor. A microprocessor is formed from the word micro and processor. It is a device that processes data and instructions. It works on binary numbers 0 and 1s. Literally, a microprocessor consists of three main units: ALU, arithmetic logic unit, perform arithmetic and logical operations; control unit, control and coordinate all operations; register, temporary store data during processing. The microprocessor takes input, process it and gives output. Next one is a microcontroller. A microcontroller is a small computer on a single integrated circuit. It contains CPU, memory, and programmable input output peripherals on one chip. Microcontrollers are widely used in embedded systems. They are used in home appliances, automotive systems, medical devices, and industrial control systems. Microcontrollers are programmable so they can be customized to perform specific tasks. A microcontroller is a high speed device but slower when compared to a general purpose computer. Now, embedded systems. A embedded system is a system that is closely integrated with a main system. It usually does not interact directly with the user. The embedded system is made of hardware, application software, and real-time operating system. It can be a small independent system or a part of large combination system. Sensor collect input from the environment, and analog to digital converter converts the analog signal into digital form. The processor with memory process the data. The digital to analog converter converts the digital data back to the analog. Actuator performs the required operations. Microwave oven. A microwave oven is a electrical appliance used to heat and cook food. It works by the exposing food to electromagnetic radiation in the microwave frequency range. The microwave oven have different operating modes. The main modes are convection mode, microwave mode, grill mode. Microwave oven modes. Microwave mode used for cooking food like rice, Maggi, boiling potatoes. In this mode, the magnetron generates high frequency microwave. This microwave cook food from inside to outside. Next mode is grill mode, used for grilling and baking items like cake and cookies. In this mode, the heater turns on. A fan circulates hot air inside the chamber. This gives a baking and grilling effects to the food. Requirement of project software. The tools will use MPLAB ID, the digital notebook where we write our code. Exit compiler, a translator that turns our human written code into the computer language. PICSIMLAB, a simulator that lets us test our project on a computer screen before we build the real things. Hardware. PIC18F877A microcontroller are used. The main computer chip microcontroller that turns the whole show. Timer 2. Like a internal stopwatch, it helps the chip keep track of time perfectly. Interface 16 16 for CLCD, a small screen that displays four lines of text to tell us whatever happening. Matrix keypad, a set of buttons so we can give commands to the project. Next is interrupts. An interrupt is a signal that gets the CPU's attention. It tells the CPU to stop its current work and handle the something urgent. The CPU runs a small program called ISR, interrupt service routine, to deal with it. After that, it goes back to what it was doing. An interrupt vector shows where the ISR service routine is stored in a memory. All interrupts are linked to a vector table in a memory. Each interrupt has two bits, one to enable it and one to detect it. The GIE bit, global interrupt enable bit, can turn all interrupts on or off. GIE helps keep important parts of a program from being interrupted. Interrupt service routine ISR. The code that is run when an interrupt occurs is called an interrupt service routine ISR. It is a special function that only runs when there is an interrupt. The ISR should always clear the interrupt flag that triggered the interrupt. If you do not do this, another interrupt will occur immediately after ISR completes. This will effectively the operation of the main function. On interrupt, CPU complete the current instruction and push PC address to next instruction on to stack and clear GIE to disable further interrupts. Slide internal block diagram of PIC16F87. The block diagram contains programmable program memory, program counter, EEPROM data memory, RAM file register, address multiplexer, file select register, multiplexer, instruction register, status register, arithmetic and logic unit, working register, instruction decode and controls, ports, port A0, B0, ports are port A, B, C, D, E. Now, peripheral features of PIC16F877A input output ports. PIC16F877 has a 5 input output port. Each port has two control registers. Trees set whether each pin is an input or output. Port outputs set their output bit level or contain their input bit level. Analog to digital converter ADC only available in 40-bit and 16-bit cores. The result is a 10-bit digit number. And another features of PIC16 F877A timer or counter modules generate interrupt on time overflow, can use external pin as a clock in and clock out, that is for counting events or using a different FOS. There are three timers or counter modules: timer 0 8-bit timer or counter with 8-bit prescaler, timer 1 16-bit with 8-bit prescaler, can be incremented during sleep via external crystal clock. Timer 2 8-bit timer or counter with 8 period register, prescaler and postscaler. Keypad. The matrix keypad has a 3 columns and 4 rows. When you press a key, it connects a row and a column together. The system detects which row and column are connected to find the press key. All rows are usually kept high 1 using pull-up register. When a key is pressed, the signal goes low 0 for that row and column. By checking the row and columns, the system knows which button was pressed. Now see LCD display. LCD stands for liquid crystal display. It is used in digital device to show characters or messages. It works by controlling light passing through liquid crystal cells. Common types are 16 into 2 and 20 into 4 LCDs. 60 into 2 means 2 lines 16 character each, and 20 into 4 means 4 lines and 20 characters each. A standard LCD module usually has 40 pin for connection, and in this project use the 16 lines of CLCD. And now microwave oven simulation on a PICSIMLAB. The microwave oven is simulated using PIC microcontroller in PICSIMLAB. The setup including LCD display to show time and status, keypad to set timer and start and stop cooking, LED to indicate power or cooking status, buzzer to signal when cooking is done. The program controls all components just like a real microwave. The simulation helped test the circuit and code without real hard work. Now, discuss the actual working of the microwave oven on simulation software is the PICSIMLAB. First, load the hex file. Click on File, Open. Hex file is loading. Now click on Debug. Power is on. Microwave oven is the start. Now four mode are displayed on the display display screen. 4 mode is micro, grill mode, convection mode, and start mode. Press 1, then start the micro mode. Press 1. Enter the time 9 second and click on hash, then enter. The microwave oven is the start. Cooling fan is also start. Counting 3, 2, 1, then time is up. Now select the grill mode. Press 2. Enter the time is 20 second. press hash enter. Now counting is the start. You can counting start or resume. You can pause. You can press 6 then stop the counting. Counting is start 6, 5, 4, 3, 2, 1. The time is up. Now select the third mode. Press 3. Enter the temperature. Temperature is 100 degrees Celsius. Press hash. Then preheating is start. And last mode is start mode. Click on 4 the start mode type and counting is start. You can press 5 to pause. You can press 4 start and 6 press stop. Time is up. This is the actual working of the on PICSIMLAB of microwave oven. Thank you everyone for watching my presentation on the microwave oven simulation using PICSIMLAB. Through this project we learn how a PIC microcontroller can control components like the LCD, keypad, LEDs and buzzers just like in real microwave oven. This simulation helped me understand embedded system better and how hardware and software work together. It was a great experience to design, test, and observe the working of the system virtual.